What is the inspiration behind the creation of the series is one of my own experience. I was leading a team, rather I am leading a team of a big data. We are currently working on technologies such as Hive, Spark, Hadoop, MapReduce, and all of them are based on Python. So we were happily trolling around and we were getting a lot of work in that as well. But suddenly, like almost 8 to 9 months back, we started seeing that our client is having his focus, he want our focus to move on to a completely newer side, that is cloud. He has got a mandate from his managers or maybe some of the top bosses from his organizations that they wanted their on-premise technologies. When I say on-premise, everything which is Hadoop, Spark and Hive, everything was based on their on-premise, like they own their clusters and everything. They were maintaining them, so everything which they had was available to them on-premise, but they wanted to explore the possibility of moving those entire things onto cloud, and then began the journey of exploring the applications which we were running on-premise onto cloud. So I just wanted to share this journey. That is one of the inspiration. Second is environment around us. So more than 70 to 80% of my colleagues and friends are consistently talking about the movement onto cloud in some or the other way. Maybe they are in a development team and they have been asked to migrate their entire DevOps process, or even the development that they do, even the IDEs that they use for development such as Visual Studio and all those things, to be migrated to cloud. Some of them production support teams which were playing a greater and important role in supporting some of the production applications, so they have been given the mandate to try to learn the cloud technologies and try to get their hands on that and be ready if the entire production environment moves on to some or the other cloud. So environment around us is all about cloud, cloud and cloud. But the third point which I have mentioned here is there is more information, more confusion than information. People are more confused because there are a lot of vendors involved in it, and like lot of my friends talk about then this Google Cloud and then AWS Cloud, then there is Azure Cloud and then some of the other vendors as well. So there is lot of confusion than information. So this entire series will explain what these cloud technologies are all about, and based on our experience we'll tell you how we classify them, how we clearly demarcate them for our understanding. So what is the major intention for this series is putting our knowledge in the form of series that would help us understand what cloudification wave is all about. So we see there is a cloudification wave and we wanted to see what this is all about. The reason why we hear cloud word all along. Create a learning path for some beginner to start with. So for every journey, a 1,000-mile journey also begin with a step. So this is, we can say, just a step so that a beginner can understand how to distinguish between technologies and there is no confusion that remain in his mind. Then making the audience familiar with jargons related to cloud. So when we use this cloud word, there are a lot of other jargons that come in: serverless, server, managed, unmanaged services, and then the data migration and all those things, lot of hundreds of things that come along. So we just wanted to educate people, educate a beginner. There is no prerequisite, just sit back, relax and understand how this wave is turning on us and how we can take an advantage out of it. In next 2-3 slides I'll just go through small stats. This is one of the data that is available in the public domain. I just googled it and I'll share the link in my comment section as well. So this just tells us what lies ahead of us in the next year. So if the name of the slide itself, don't go into too much of a depth of this slide, what information it gives. I'll explain you in short what does this information represent for each of the slide. To begin with, let us understand this slide, IT business growth for the year 2020. So what this graph tells us is whether IT industry as a whole is there. Each year, each and every organization is allotted certain IT budget. For example, let's say a particular organization has a revenue of $50 billion. So they say that okay, we are going to spend around $1 billion or $2 billion on our IT budget. So each manager accordingly, rather a manager of IT department get that much of a money. So this is what is this budget information is shown. So for the year 2019 to 2020, that is next year, we see that 44% plus 44%, these colors represent no change or increase. So we see that almost 88% of the people say that either the IT budget is going to stay steady, that they are going to have the same budget, or they are going to have an increased budget. If we see 44% of the people say that they are going to have an increased budget. This is just, I am telling you that the pie is lot. The pie is huge, means there is a huge scope that next year we are going to see lot of money getting pumped in. But then we must understand where this money is going to flow. So if we consider the second slide here, don't go into too much of detail of that. Just check the first thing, factors leading to increase in the budget. So if we see the first priority factor, so 60% of the people feel that the increased budget is going to go in need to upgrade an outdated infrastructure. So this, I'll tell you a small example. I have worked with some of the multinational companies as a from vendor side, of course. So we as an IT vendor, from an IT vendor side, and many of my colleagues work in some of the top financial firms in their IT department as well. So they also share their experience, and based on my experience as well, most of them have an outdated IT infrastructure for them. When I say outdated IT infrastructure, it doesn't mean they have older laptops or anything or such things. They have their server technologies are lagging behind what is available in the market right now. Because even in the industry terms as well, these financial services and insurance, they are the late adopters of some of the technologies. So right now their server infrastructure, their data center is still in very much outdated format. So next year they are going to have a need to upgrade this outdated infrastructure. So this is the main reason. You can see the difference. What is the main reason for them? And second one is increased security concern. So this doesn't mean a lot to us. This is the main reason why we see cloud a lot. Third is top drivers for hardware. So why there is, so we have seen that there is going to be an increased budget. Second, we saw that this increased budget, the main pain point area for them is their outdated infra. The third graph shows us top drivers for hardware purchase. So what is going to drive them for this is end of life, refresh cycles, then project need and growth, and then end user need and budget availability. Need technology feature. So leave all these things, but end of life and refresh life cycle tell us that most of their IT infra is not in a state right now to handle the current load or to handle the cost effectiveness that the industry want to see. I'll just give you a simple example. Currently we have an data center, which means the organization for which we work as a vendor has a big data center, and they want us to explore, the first thing that they want us to explore, the possibility of not using that and migrating onto cloud. They just wanted at each and every step the cost comparison, because we hear a lot that the IT budget or rather we can say that there is a need for every person to be cost effective. Means this word we hear a lot from all of us who work with the IT vendors and through them to multinational companies. We hear this cost effectiveness a lot. So for each and every one of us, the mandate is to search for the possibility of having less cost if possible on cloud and not to use the on-premise infrastructure. So this is the direction, or this is the wave towards which we are moving. So, and this is the reason, so what this entire thing tells us, that there is an increase in budget. Where that is going to flow? That is going to flow into lot into infra, and that is going to be a driving point why people want to move on to a cloud. And in terms of budget allocation as well, if we see that there is more than 29%, or even if we add hardware and hosted based services, it means 29 to 33, almost to 60% of the things are going to have a change or are going to have an impact in the next coming year. And this is the reason we are seeing that everybody at our colleagues or everybody at our client organization is talking about cloud. So what in the next episode, in this episode we have just seen why we are hearing a lot about cloud. In the next episode I am going to make it point by point the reason why we are moving on to cloud, right from its benefits to the exact point for which everybody is talking about cloud. In this we are going to see in the next video. I would like to conclude by saying that in the upcoming year we are going to see a cloud burst. Everybody is going to be on cloud, whether it's a small vendor, a larger vendor. The point where they see that there is an efficiency or there is a chance that they could improve the performance, they'll run in. So I am just quoting one of the website which says that when it comes to the top IT challenges in 2020, keeping the IT infrastructure up to date will continue to be a top pain point. So with this I would conclude this video, but in the next video don't forget to see, I am going to tell you point by point why every organization is benefiting and what is the exact reason for which they want to migrate to cloud. So thanks for watching this video, and we'll continue on to the next video. Thank you. The first reason behind the cloud adoption is cost. There are a lot of cost associated to maintaining the infrastructure for the organization. The IT infrastructure forms the backbone of majority of the industries today. Right from banking, financial services to insurance to manufacturing, IT infrastructure plays an extremely critical and important role. There is a cost associated to it. The first cost is they need to maintain a real estate, which I have mentioned in the point number 5. They need to have a place where they can have their data centers. Those data centers need to be managed by a well-trained staff, and the organization has to spend on maintaining those data centers, and those personnel who have enough knowledge or are very well trained to manage that entire infra. There is a cost associated to maintaining, right from the energy that we supply to those data centers, to the energy that goes into cooling them off, to the lightning, and all those things plays a very important role in cost. Then there are a lot of licensing that the company has to maintain. Suppose they let's say, just to give an example, we as a big data team have a huge cluster, and that associate itself with the cost of Hadoop licensing, which we take from let's say some of our licensings are from Cloudera, some of them are from Hortonworks. So all those things are there. Then there are associated, for example, if you use some visualizing tool, for example, let's say if you use SAS or Tableau or QuickView, then those things also has the licensing cost. Their versions needs to be maintained, their version needs to be upgraded on our own entire infrastructure. So all those things are there, because those things such as Hadoop, Spark, or anything related to Tableau, QuickView, or even some of the .NET related stuff like the Windows servers and all those things needs to be maintained and managed entirely by the organization itself, and there is a cost associated to it. Whereas the cloud adoption, we get the benefit because most of the cloud today has a pay you use model, that pay only for what you have used. We just go there, plug in. Let's say, for example, we wanted to run one web service. So we just request a server, we just host that web service, and we, let's say, wanted to host it for a month or so. So we just go, then buy the time on server for a month, we host that service, and then we turn it off. So we don't need to have a person who looks after where that server is going to be placed, where the person need, since there is no need of a person, we don't need to have, since that server itself is not in our on-premise, there is no need for us to care about who is going to maintain that server. So this entirely reduces the burden on the organization to maintain and manage that infra, and this definitely give the organization more time to focus on its core business, which might be a banking, which might be financial services, which might be manufacturing or something else, than maintaining the IT infra. So this is the major reason why everybody wish to adopt to this model. It's a pay you use model. So in conclusion, we can say the cost of acquiring infra maintaining is reduced, and to maintain the army of personnel to run the show of the infra team is also reduced to fraction or negligible. So this is one reason why there is a widespread adoption of cloud. Cost. Second is time and scalability. I'll give for each and every point I'll give some examples. So point number one is difficult or takes time to scale the infrastructure when needed. For example, I'll tell you one of my own experience. Few days back we needed a service which we needed to install on a specific size of server which was not available within the organization. That our manager needed to take an approval which was more than 50k. So our manager doesn't have the right to take that much of the approval. So he went on creating the request and then went on to getting it approved, until the time the year end came and the budget got frozen and the request went into pending state. And this entire exercise continued for around 1 or 2 months. So ideally the thing which we would have tried and tested immediately went into loops and loops and ending up with no result. So this is one of the issue that is there for the on-premise thing. So the time associated is fixed and it might be huge. Second is we end up under capacity or being over provisioned. We have one of the account services or the transaction services which are needed to be scaled up because they are used like a lot during the Thanksgiving holidays and some of the American holidays which comes around like Black Friday and all. So there are a lot of transactions that happen. There is a huge load on the server. So we always keep the extra capacity ready, which is no longer used when that load slows down. Right after the Black Friday or even after the Cyber Monday, the amount of requests that comes in drops more than 30 to 40%, and we are still with the same capacity. But if we would not have provisioned those, we would have ended up in creating the nuisance for our customer. So anyways, we would either be under provision or over provision. So this is one of the reason why, or rather we can say, difficulty with the on-premise. Third is time for approval or experimentation is more. In the first example itself, I have told you that we needed to evaluate one software on one of the specific machine or specific configuration machine which was not available. So same thing happened. Same point is repeated in the third one. Time for approval or experimentation. Microsoft Power BI is one of the leading tool which is now getting used. So we didn't had a specific version of that tool available with us. So we didn't had any other place to go. So we asked the infra team in how much time that particular thing could be made available. So he said that it would take at least 7 to 14 days for the software to get approved for the commercial licensing and budget approval and all those things. So these are the things that come in the way. Fourth point is time to implement a new feature is more on-premise. Let's say if you would have successfully able to quickly test the Microsoft Power BI, we would have been able to adopt more quickly. So we can say that time to increase the capacity is reduced, time of adoption of new technology is less, and thus the overall time to market for us is also reduced. These are the challenges that we faced on-premise. So first reason we saw was cost, second reason is time and scalability. And moving to third reason, this is most important reason, which is data protection and data privacy. Nowadays there is a huge burst on the organization need to maintain their data privacy, and it is extremely crucial. The wave started from Europe where GDPR was adopted, and then it traveled back the entire world where each and every person got aware that his personal data need to be maintained well and securely by the organization which owns it or which manages it. So data protection and data privacy plays very important role. So then there came a lot of things in that, like we need to have certain kind of encryption, we need to have certain type of algorithm to maintain the data privacy and data security. So all these things are non-core business of our organization. So many of our organization don't want to get into it. If some third party is able to provide the tool, or if some third party is able to provide some infra which is secure and we can directly plug in and take the help of that to adopt that, then that would be great for them, because there is a cost associated with maintaining those security algorithms and those certificates on the servers and all those things. So that is one of the reason why people are moving on to cloud, where all these things are maintained or handled by the entire cloud infra team itself. That we just talked about is data privacy, but what about data protection? So backup and recovery, this is one of the important things. So I'll give you one of the example which I have seen. There was this application where my financial services organization used to maintain the paper bond. Then they adopted and then they moved on from paper bond to some application where they used to maintain the bond in the form of soft copies. But then the Katrina disaster that came approximately I guess 2012 or something in US, which flooded the New York City, and one of the server places that organization had got also flooded. Luckily they had the backup center which was there onto the core part of or away from the shore, and that facility was having a backup and recovery of the entire data center of this which was flooded in the New York, and they were able to save the data. But imagine the situation where we don't have such thing available and we are not able to protect the customer data, because IT and data being a backbone of the entire story, this needs to be protected and maintained. So data protection and data privacy plays extremely important role in this. So for the first reason was cost, second reason was time and scalability. First reason was cost, second reason was time and scalability, and third is data protection and data privacy plays very important role. Now in each and every case, in cost we have seen that cloud is a pay-per-use model, so that is one of the benefit. Time and scalability. The time to provision an infra or to get any particular service is rather, you can say, fraction compared to what we could have got in our own organization. And third is data protection and data privacy. The cloud teams have their own security teams being deployed and they are maintaining their infra and everything. So the organizations which are like banking, financial services or manufacturing or any other thing can focus on their core business instead of getting into all these things. So these are some of the reasons why we wanted to adopt the cloud. So industry adoption wise, this is just short. In short, I'll tell you how the industry generally we have seen adopts. So retail and analytics firm are the first one to adopt technologies. So example is Nielsen. Manufacturing is the second one, and in the last, because these are like organizations which are skeptical about it and they have their own reasons, definitely banking and financial services and insurance. So these are the industry which are now in next year 2020 are going to see a widespread adoption of cloud technologies. So majorly IT industry in India, or rather we can say over the world, deal with banking and financial services all over the world. This year and next year will be the time when the banking and financial industry will be seen widely adopting cloud practices. This indicated a big wave of cloud and cloud technology related work coming in our plate. So be ready with your surfboards. The wave is coming and we are going to fly in it. Thanks for watching this video. In some of the next videos, what we will see is a use case by use case approach of how we are going to do some of the POCs or experimentations on the cloud, because there is no written handbook that okay, X is going to be X, Y is going to be Y in cloud. The solution architect who sits down has to take a comprehensive approach when he moves the on-premise application onto cloud. In some of the upcoming series, we'll get onto that hat. Thanks guys for watching this. To the use case. In this video, I'll explain only the use case. So it is about file processing and storage application. When we are working into any of the organization, as in the IT department, we as an organization get information from multiple sources. Now those sources, for example, if you are working into the bank, you will have user data coming in, you will have financial data coming in, you will have data coming in from different analysts and all those type of sources. Now that data might come into multiple formats. It might be CSV, Parquet, TSV, Zip, XML, JSON. It can be of any type. There are always some applications which are responsible for reading the data, filtering the data, enriching and writing to the storage. This we call it as the processing engine. So whatever the source is, we get file from multiple sources. We'll always have one processing engine which will be responsible for reading, filtering, enriching, transforming, and then again writing it to some storage. Now storage, the data is used for analytics or as a data source for multiple web services. So storage can be of any type. For our case, we'll consider a simple use case that data is coming in the form of CSV file. There is a processing engine which is written in Python that is going to read the file, and then it is just going to read, do some extremely minor filtering and enrichment, very simple filtering and enrichment, and then again storing it back into some database. So this is the use case that we are going to see. CSV file coming in, a Python job which is processing that application and then storing it into the relational database. So this is a simple use case we'll see. Now in the next upcoming video, what we are going to see is how we took this challenge and then explored what all options in the form of services are available for each of these section. let's say files coming from multiple sources. So what are the options that are available for us to get the files from, where we can get the file, then what are all the different type of processing engines available, and what are the options there, which type of web services or services are provided by the cloud, and what are the different type of final storages available in the form of either it's a relational database or non-relational database. So this is what we are going to see in an upcoming video. So stay tuned for this, and thanks for watching. So let's consider our first use case. Our use case is file processing and storage application. What we generally do whenever we try to convert any of the existing phenomenon or existing application onto the cloud is first we draw a diagram of what we are going to have as a component. So in this use case we have component the files coming on to the cloud. The files those files will be processed, that is the information will be extracted from that, and then we will store that file data into the database. So this is our use case. Let's start from the first. Since we are getting the file, there is definitely going to be storage required for that file. So we go and search on Google, we do a simple Google search, what are all the storage options available on Amazon, and the answer that we get is, the first search is Amazon S3, simple storage service. Now what is Amazon S3? So even if we click on the first link, we'll get to aws.amazon.com/s3. There the AWS describe Amazon simple storage service as an object storage service that offers industry-leading scalability, data availability, security, and performance. This means customers of all sizes and industry can use it to store and protect any amount of data for a range of use cases such as websites, mobile applications, backup and restore, archive and enterprise application, IoT and big data analytics. So all these use cases are given or usages are given, but out of that what our need is to store the data, or rather store and protect any amount of data of, let's say, any of the application. So basically from the definition it seems that okay, this is kind of an useful service. Let's also see a short introduction video of what Amazon S3 is all about.
Companies today need to simply and securely collect, store, and analyze their data at a massive scale. But today's fragmented data storage portfolios force businesses to struggle with complexity and slow down innovation. That's why AWS Storage Services give you a place to store all of your data with unmatched durability, availability, and scalability. With a reliable infrastructure, tools for compliance, security, and storage management, a massive ecosystem of integrated third-party software and systems integrator partners, and that works with your business processes and even enhances those processes by allowing anyone to securely run queries of their data without moving it to a separate analytics platform. Amazon Simple Storage Service, or S3, lets you collect, store, and analyze data in any amount from anywhere. First, durability. With the largest global cloud infrastructure, Amazon S3 was built from the ground up to deliver 11 nines of durability. S3 Standard Infrequent Access, and Amazon Glacier storage classes store all of your data redundantly across 3 availability zones that are separated by miles on separate power substations and connected to other AZs and the internet on multiple, physically separate fiber paths, keeping data written to a single AWS region protected, even in the event of an entire availability zone loss. S3 One Zone IA gives you the option to store reproducible data in a single AWS availability zone, trading lower fault tolerance for lower cost. And with all of these storage classes, you have the ability to replicate that data to any other AWS region.
So basically this gives us enough of a confidence that okay, S3 is a service to go for our storage requirements. So and there is also one important point which I want to highlight is S3 is designed for 99.99% of the durability and stores the data for millions of applications of companies all around the world. So this gives, we finally decided that we are going to go ahead with the S3. Let's in short see some of the benefits. Is industry leading performance, scalability, any amount of data you can store. In terms of availability, we have just seen it's 99.99% durability is there, and the data is all made available in the form of these replicated availability zones, which makes sure that even if there is a complete loss of an availability zone, your data is safe and secure. Wide range of cost effective storage classes, wide range and unmatched security and compliance audit capabilities. So we are now confirmed that for our use case, the storage place is going to be Amazon S3, and we have now decided. In the next video, we would explore on console directly how Amazon S3 is and what all things we need there to store the file. Thanks guys for watching. Let's explore this service onto AWS console. This is a AWS console that we get right after logging into AWS account. We have to search for a storage service. So if we click simply on this service tab, we get, and if we search for multiple type of services, we see that there is a storage and there is a S3 something available. So let's click on that. It will redirect us onto S3 screen. What we see here is we have to create a bucket. There is a message, you do not have any buckets. So we have to create a bucket to store any file. Now what this bucket is all about. Bucket is nothing but a storage resource available on S3, similar to folders. The way those who are familiar with Windows system, we have folders. So similar to that, on S3 there is a bucket to store object which consists of data and its descriptive metadata. So data and metadata will be stored. So let's create a bucket. So I just try to put a name for the bucket here. And click outside that and simply click on create. Nice. The S3 bucket is created. One thing you can see here is even if this bucket is created and the region is Asia Pacific, on top of that you will see it as global, because S3 metadata system or bucket naming and everything is global in nature, even though the data is locally stored within the region that we have logged in. So for S3, this is one of the most important thing about buckets or S3, and an important interview question as well, that the bucket is whether it's a global in nature or it's a local in nature. So data is definitely local in nature, because anything that you store in this bucket will be stored in Asia Pacific Mumbai region only, but by phenomenon, by naming convention and everything, it is global in nature. There is this naming convention also to create a bucket. If you go to I have searched few things about naming convention of S3 bucket. I'll just read those things out. Bucket name must be unique across all existing bucket name in Amazon S3. So throughout Amazon S3, throughout the world, whatever Amazon S3 bucket names are there, it has to be unique. You cannot have two names even if your bucket are in different region. And that's where this, by naming convention, it is global in nature. Bucket name must comply with DNS naming convention. Name must be at least 3 with more than 63 long characters. It must not contain an uppercase character, and bucket name must start with a lowercase letter or a number. Bucket name must be series of one or more label. Adjacent labels are separated by single period dot. Bucket names can contain lowercase characters, lowercase letters, numbers, hyphens. Even hyphens are also allowed. Each label must start and end with a lowercase letter or a number. And it must not be formatted as an IP address, because bucket name come in the in the link that we have, or in the link where we try to access the bucket, so it cannot be an IP address. So these are basically some of the rules that we have. So I'll just show you in one moment. Let's say if we try to create a bucket, and let's say I try to create a bucket called test. So I will not and click on create. It will give me a name. Bucket name already exists because test is very much of a common name available. But if I give the bucket name as test 07 1 2 3 4 5 and click on create, if it is unique and nothing has been created out of like such name, it will be created. It is very important to delete them as well because it will consume the it will not consume the resources, but since we don't want anything to cost to us, so we'll click on delete the bucket which we don't need. So it is saying type the name of the bucket, so we'll type 07 1 2 3 4 5 and confirm, so that our bucket is deleted. Now this is the bucket we are going to use for our use case. I have created a sample file for this use case, and what I'll do is I'll upload a file here, sample CSV file. So if I click, I'm now inside the bucket. I click on upload. Let's add the file. Let's go to the desktop, and I have lot of different things here. So out of that, let's select the sample file which I have already created and simply click on upload, and our file is now uploaded. So this is the simple way to upload a file. There are multiple things that we will do with this file, but that we'll do in the next video. Continue watching. Thanks a lot. Now that we have created a storage space and uploaded a file in Amazon S3, let's move on to the next part. We need to have a compute service. To be able to read the data from this file and then make sense out of it, create an object and store it into the database. So for that we have to explore some of the compute services of AWS. There are many services of compute services available basically from AWS side. Let's explore the management console. So if we go here, we can see compute as being listed one of the topmost option as only. In that we see like multiple options are there, but we need an option where we don't have to create a server or don't have to worry too much about what is going to be the capacity, how many servers to install and all those things. So if we do a simple search on Google, we'll get that one of the popular service on AWS is AWS Lambda. What AWS Lambda is all about? AWS Lambda is nothing but a serverless compute service available from AWS side. It runs the code without thinking about servers, and we pay only for compute time we consume. That's what the advantage of cloud is. We want to move away from our worry of having to put a request for server, then install it, install our own code and then run it, and then worry about whether we are reaching the maximum capacity or minimum capacity, over usage, under usage, lot of problem we have. But now AWS has provided this AWS Lambda as a service. In on-premise, we would create a job in Python or any other language like C#, Java or anything, and write the logic to extract and load the info into the database. But now we will do everything in Lambda. Let's see one of the short video introduction of Lambda.
When you're building applications, you want them to deliver a great experience for your users. Maybe you want your application to generate in-app purchase options during a gaming session. rapidly validate street address updates, or make image thumbnails available instantly after a user uploads photos. To make this magic happen, your application needs back-end code that runs in response to events like image uploads, in-app activity, website clicks, or sensor outputs. But managing the infrastructure to host and execute back-end code requires you to size, provision, and scale a bunch of servers, manage operating system updates, apply security patches, and then monitor all this infrastructure for performance and availability. Wouldn't it be nice if you could just focus on building great applications without having to spend lots of time managing servers? Introducing AWS Lambda. AWS Lambda is a compute service that runs your back-end code in response to events such as object uploads to Amazon S3 buckets, updates to Amazon DynamoDB tables, data in Amazon Kinesis streams, or in-app activity. Once you upload your code to Lambda, the service handles all the capacity, scaling, patching, and administration of the infrastructure to run your code and provides visibility into performance by publishing real-time metrics and logs to Amazon CloudWatch. All you need to do is write the code. AWS Lambda is very low cost and does not require any upfront investment. When you use AWS Lambda, you're simply charged a low fee per request and for the time your code runs, measured in increments of 100 milliseconds. Getting started with AWS Lambda is easy. There are no new languages, tools, or frameworks to learn. You can use any third-party library, even native ones. The code you run on AWS Lambda is called a Lambda function. You just upload your code as a zip file, or design it in the integrated development environment in the AWS Management Console. Or you can select from a list of function samples pre-built for common use cases such as image conversion, file compression, and change notifications.
Okay, so we saw how AWS Lambda is one of the best serverless compute service available for us, and it seems that it suits our use case as well, where we don't want to worry about spinning up of servers. No server we want to manage. We don't have to worry about scaling them, and we don't have to worry about cost. So whatever we use, we'll pay. And they also claim consistent performance. So these are some of the benefits that we have for Lambda. Let's see on console how we can locate it and how it looks basically. So this is a Lambda this is one of the screen which I wanted to show you guys. How I came to this screen, we'll see. So I clicked on the services, I went to compute, and then I clicked on Lambda. This brought me here. This is one of the actions which I created as a part of my test. Let me delete that because I no longer need that. I'll show you from scratch how we create a function. So what kind of a function we need? We need a function to read the file from S3 and take the data out of that and then load the data onto DynamoDB onto our database. We have not selected the database yet, of course. So this is how it is. Now let's create the function at least. So let's give the name of the function as file upload and process. So yeah, we can give this name. Let's create a function. The creation of function is as simple as few clicks away. There are multiple options available. Author from scratch, use blueprint, or browse serverless app repository. We will use the simple option, author from scratch. Let's give it a name as file upload and process Lambda. There is no need to worry about the name of the Lambda here. Just it has to be unique within the account. There are multiple language options available. People from .NET background, there is a .NET Core, C#, PowerShell as well. For Java, Node.js, everything is there. Let's choose Python. And then just simply click on create function. So it will take some time, but it will create a function for you. It gave me a message successfully created file upload and process function. I'll make you familiar with the screen also. So this is your screen specific to your function. The name of the function is file upload and process. So configuration is given. In designer we can add trigger whatever we want, and then there is this console which ID on console that the video was talking about, where we can develop the code. This is a fully testable sample that the AWS provides. Even if we click directly on this, we will be able to test it out. How to test this thing out and everything, for that keep watching. In the next video I'll explain how to create a test function and how to test this lambda which we have just created. So thanks guys for watching. In the next video we'll talk about further about lambda. Thank you. We have created a location for us where we are going to receive a file, and then we also created a compute function within AWS known as AWS Lambda to process this file. Now how the function is going to know that file has arrived? There has to be some way. So we decided to introduce a trigger to this, so that function is triggered when the file is uploaded. In this video we are specifically going to see how to add this type of trigger. Let's go to S3. Now we can see that S3 bucket is empty. Let's go to the function lambda. Here you can see that there is a trigger which was already pending for deletion. So let me delete that first so that I can show everything from scratch. Let's try to add a trigger. What type of trigger we want? We want a file creation, or we want an S3 trigger basically. So even I click on that, it will list all the buckets inside that. What type of trigger I want? All object create events. This implies there are multiple options available: put, post, copy, and all those things. But what kind of trigger I want is whenever my file is created, I need the trigger to happen. So all object create events will give, and then we can also give a prefix. What is prefix is, if a file, we have a hierarchy of folders and subfolders where we wanted to give the file present location, then we have to give prefix and suffix if we want a specific type of file trigger to happen. But for the simplicity purpose, let's keep it generic one, and then we click on add. This will tell us that a trigger study circle was successfully added to function file upload process. Now how to verify whether the trigger is properly added or not? So addition of trigger in the function or lambda will add an event into S3. How we can verify that? Let's go to study circle, let's go to properties, and if we go down, it would have added one active notification. You can see that all object create event for lambda has been added. Okay, now let's try to trigger this. Now how this is going to be triggered, and any upload of file within the bucket is going to trigger. So let's do that then. Let's try and add some files. So we upload a sample file. The moment file is uploaded, an event would trigger and a file upload lambda would then be notified and it will be triggered. Now how we can verify that our lambda has been triggered? There is a way to do that. So the moment we come to this screen, click on monitoring. Sometimes it takes a few minutes for logs to be captured, but sometimes they are very fast, but generally it takes few minutes for logs to be captured. So for now we are just seeing that two events have happened. These are the previous two events. I am waiting for the third one because these two I have created for my test purpose, so I have I need to see a count of 3 here. So let's wait for a few minutes. It might not take much longer. It would take just, I can say, 20 to 30 seconds or maximum 1 minute for the logs to be available. So what I've done is have reloaded the file, and they have not yet arrived. So let's wait. Let me pause the video. Okay, there is no need to pause. We can see that logs have arrived. So in recent invocations, we can see that Lambda has been invoked. The reason for that has been also given, that this is the Lambda which was invoked, and this is the request ID for that, and what is the billing summary, and everything has been given. So this is how we have added a trigger to the file upload, which implies that any file upload that will happen, let's say any kind of CSV file or any kind of file will be uploaded here, this Lambda will be triggered. Now this is a heavy operation, as in continuously we have to upload a file to test it out. So there is another way, or there is a nice way that Lambda has given, is to configure some of the test event, so that we don't have to continuously upload a file. We can configure the test event, and we can test the function right from here. Now how to do that is, for that we need to get the JSON or the request that comes to the Lambda and kind of create a test case for that. Let's see how we can do that in the next video. Thanks guys for watching. We have learned how to add a trigger to a Lambda function, and we have successfully added the trigger to a Lambda function. Now in this video we are going to learn how to create a test event. First of all, let us understand why we want the test event to be created. Our trigger is a file upload to an S3. Now while we are doing the development, we don't want to be disturbed, and we don't want to be continuously uploading the file. Let's say if we wanted to test some 20 KB or 30 KB of a file, or let's say 20 to 30 MB of a file to process. So it takes time to upload, it takes the network bandwidth. So for that we have a workaround. We will create a test event which will take the file from here only, and while we are doing development, it will help us to get the same request to the Lambda. Now how to configure a test event? That is one of the most important thing. For that, this is something what we do. First of all, we will simulate the scenario. We'll try to get the result, and then we will use that result to create a test function. Now how we will simulate the scenario? Before simulating the scenario, let's do one thing. In the Lambda, just make one small change. Print the event which you are receiving. The event is nothing but the input JSON that we get for Lambda. We are just going to simply print that. Just save this, and we will, first of all, let's trigger this by actually uploading a file. So let's delete this to avoid any duplicacy check. Let's delete this file, and let's recreate the scenario. Add files. So we uploaded. Now the moment we click on upload, the file has been uploaded. So this must have triggered the Lambda, since we have added the trigger to it, and this time it might have printed the event. Now how to check that? So for that, just go above, go to monitoring tab, and click on view logs in CloudWatch. It is going to open the log location of CloudWatch. Here you see the log come in the form of streams, AWS Lambda, the name of your function. This has been triggered just now. So if you click on this and expand this, you will see that the event has been triggered. the event has started and it has printed the entire text. So just copy this text because we want to simulate the process, right? So just copy this text to any of the notepad, paste it, and this is the input JSON, but the format is a bit uh, format is bit wrong. So what we will do is we just have to simply replace single quote with double quotes, and then we click on replace all. Now let us copy this entire text, and now let's go back to our Lambda function. In this, we will try to configure the event. Let's click on, I have created the earlier just to showcase you guys, but let's do it from the beginning. Create new event. Now give it a name, test file upload 1, and just paste the entire thing. Okay, so this is the kind of a event simulation we can do. Now what is inside that? It says that S3 bucket name called study circle, some file called sample1 has been uploaded. So we have simulated the event text, and then we will click on create. We click on create, so it is going to create a test event for me. Now I just don't have to go back and continuously upload for me to test any of the statement in Python that I wanted to test. Now simply if I click, it is going to generate an event. It is going to simulate that okay, a file has been uploaded, and similarly I'll start getting logs here. So what all things we have done, let's recap. Our aim when we started this video was to create or simulate the scenario of file upload and correspondingly create the test event. So for that, what all things we did, we first added a print statement to print the event, and then we actually recreated the event by uploading the file. The moment we did that, in the logs the event was printed, which is nothing but this. We copied the text of the event, and then with the help of this text we created a test file upload event. How we created that? So for that we clicked on configure test event. In the configure test event we clicked on create a new event, and inside that we put the JSON. But before that we also modified the JSON by simply replacing the single quote with double quote. We corrected the JSON properly, then we changed the text here and created this new event. Now this event can be continuously used. We don't have to upload the file. This event can be continuously used to test out or recreate the scenario without actually uploading the file. So this is very helpful when you do the development or when you want to check some minor changes inside the code. Having a proper test event helps a lot. So thank you guys for watching this. In the next video we are going to see how this lambda right now, lambda which we have created, file upload and process, is able to read the file from there, right? So in the next video we are going to see how this is happening, how this lambda has got the access to this. So thanks for watching, and in the next video we'll learn something new called IAM. One of the most important thing which I wanted to discuss in short is how lambda which we created, file upload and process, is capable of reading a file from S3, or even for that matter write the logs, because all these are different systems in themselves. These are all the different services in themselves. So how this is possible is, this is possible through a service known as IAM. This IAM service will create another videos in detail, but in short I'll tell you, IAM stands for Identity and Access Management. This manages the access capabilities of different services so that services are capable of accessing each other, and um, that all those roles, policies and everything is defined there. So let's see how the IAM looks like. So we went and searched for IAM. So when we created the function in the initial part, we never bothered about adding any kind of IAM role or anything there. The reason behind that is, when we created Lambda and when the configuration screen came in, there was an option of choose or create an existing role. Choose or create an execution role, sorry. So either you can create a new role or you can use an existing role, but we went with create a new role for the Lambda, for the basic Lambda permissions. But now, since we wanted to understand how this works, we'll see how to create a new role and how to use that. So when we created a Lambda function with a new role with basic Lambda permissions, how it was created? If we go into IAM and check this is the IAM screen. Basically, on the left hand side you can see multiple options that are available inside IAM, and you can click on roles, and if you scroll down you will see some of the basic roles are given. So this is the kind of role which was created when we created the Lambda function. The name of that role is file upload and process role. We can check our Lambda function what kind of role it is using. So if we go back and check our Lambda function, we can confirm that name service role, and we can confirm that name file upload and process role. So this was automatically created by AWS for us, but let's say we want to create that. Uh, the reason being, this role might be generic or might give an access to lot of systems and services which we don't want. We always want the role to be very specific. That is the best practice behind that. So to have that kind of role, we would want the customized role to be created. So the process for that is, let's start creating the role. What kind of service we would include? So it is Lambda that we want to create a role for, and if we go down, we click on next, what kind of permission we want to give. So there are multiple policies which are available. These are all the policies which are created from AWS side itself. So from this we will choose, you can create your own policy as well. We will learn that as well, but right now let's use the AWS basic Lambda execution policy. Basic Lambda execution rule. So we will use this. This basically gives Lambda enough of a permission to read the file from S3 and write the logs onto CloudWatch. So let's click on next. We can give it a tag for cost monitoring purpose. Let's give it as cost center. Let's give it as, let's say, 11, just as a sample. Click on next, review, and here you can put the role name as file upload trigger 1, and then click on create role. This file upload trigger 1 role has been created. Now the next job for us is to change this role to this. Let's refresh this so that the newly created role is coming up here, and we have changed the existing role to file upload trigger 1 we just created now. Let's click on save, and then again let's click on test. So if we check, the execution has been succeeded. So this is how we created a basic, we replaced the originally created role with our existing role. Now let's say in the future we'll take a detailed video of that, but for now just see what we created when we created this role. So this is something which gives the summary of that role which is created. Every role has their own ARN, role description is there, then paths, creation time, and the most important thing is we can check the role inside this, what is present inside that role. So basically role is nothing but JSON, um, JSON which is properly formatted and everything, which tells us what is the importance of that role is. So this role is AWS basic Lambda execution role, which allows creation of log group, creation of log stream, and put the log events, and all the resources access right now it enjoys. But then we will, in the next video, we will see how we can restrict that access only specific to S3, and that too to a specific bucket. That will help us to minimize the unnecessary accesses which might come with this resource star. So keep watching this video, and in the next video we are going to see how to trigger the file and then extract the information out of it to store into the database. Thanks guys for watching.